Okay, so finishing up this section, we're looking at other ways to solve. Yesterday you looked at if they had the same base, what did you do with your exponents? You set them equal to each other and solved. Those are probably your favorites, right? They were the easiest ones to work through. Other than that, if they had different bases, what did you do? You had to take the log of both sides. What if it had an e? Took the natural log of both sides, the ln, right? All right, what happens, though, if they both already have a log on each side? What do you think here? Log base 3 of something equals log base 3 of something. What must be true about the somethings? They have to be equal to each other. Yeah. So for something like this, just like we did yesterday when they had the same base, so the exponents had to be equal, here, log base 3 is the same on both sides. So this stuff must be equal to each other. Yep, so we're solving for x. So since it's log base 3 on both sides exactly the same, we'll just set whatever's in their parentheses equal to each other. Okay, so we'll go ahead and solve this. Subtract x, add 1. So we get 4x equals 8. Divide by 4, x equals 2. Woohoo! Easy one, right? Start off the day good. Now, one thing I do want you guys to keep in mind is we do need to check our answers. Okay, at least a little bit of a mental check, because something's going to happen. You're going to end up with extraneous solutions. Yay! Anytime you have an x in here as part of like log base 3 of something, if your x is falling inside of there, you cannot take the log of a negative number. Right, so in other words, if my x value is negative, that's not necessarily wrong. You have to plug it back in. So if I plug this back in, 5 times 2 is 10 minus 1, 9. It's not negative, so I'm okay. If I plug it in on this side, 2 plus 7, 9. It's not negative. I'm okay. But if you take your value of x and you plug it in here and it's negative, that's an extraneous solution. Because remember, that would be asking, like, 3 to what power equals a negative number? You can't multiply by 3 by itself any number of times and make it negative. Okay, so if you end up with a negative number inside of there, then it's extraneous. And we'll look at some that do end up extraneous. Okay, now all those properties of condensing and expanding that you guys love so much, you have to use them. Do you notice on this one, I don't just have log of something equals log of something? Right, I got some other stuff. But I know if it's minus with logs, what is it really? It's division. So we need to use those properties to put it together. So log base 6 of 3x plus 14, since it's minus, it's divide by 5 equals log base 6 of 2x. So if you're looking at a problem and you don't have log of something equals log of something, you're going to have to condense some things down using those properties to make it like that. Okay? So now since they're both log base 6, what do I know about each of those parts? They're equal to each other. 3x plus 14 over 5 equals 2x. How do you solve that? Yeah, multiply by 5. Now, if you're unsure, I know some people, this confuses them to no end. Think of it this way. If I put that over 1, what would you do with that? You'd cross multiply. So when in doubt, just put it over 1 and cross multiply them, and they'll go together just fine. Now you tell me that. Okay. No. Okay, you're fine. All right, did you guys loopy swoopy? What's the base number? Yeah, so 10 squared equals 5x times x minus 1. Good. Ramon. Seniors. Yes, since there's an x squared, we have to set it equal to 0. So 5x squared minus 5x minus 100. Yep, let's take the 5 out. That'll make our numbers a lot smaller. You remembered GCF. I'm so proud. Doesn't that look a lot nicer to factor? I was proud of one, not proud of the other. Perfect. So negative 5 and a positive 4. So x equals. Does this 5 right over here, does this give me an answer? Good, there's no x. That's just baby brother. The negative 4 is what? Garbage? Why is it garbage? Good. Now the fact that it's negative is not necessarily a problem. When I plug it back in, 5 times negative 4 makes a negative, so that's no good. If I plug in a 5, 5 times 5, not negative. 5 minus 1, not negative. So x equals 5 is the only good answer there. But I don't want you to get into the habit of being like, oh, it's negative, wrong. Okay, the fact that it's negative here doesn't necessarily mean it'll be negative when you plug it in up here. Okay? All right. 2 times log of 5 equals of 3x equals 4. What? Yeah, let's divide by 2. So log base 5 of 3x equals 2. Bless you. Then what? Loopy swoopy. 5 squared equals 3x. So 25 equals 3x. Divide by 3. Does that divide nice and pretty? No. What do you want to do with it? Do you want to leave it 25 thirds? Do you want to divide it? I'm lazy. I'm going to change it to 25 thirds, but sure. All right, guys. How about 5 plus 2 log base 3 of x equals 4? Good. Oh, you're fine, hon. Subtract 5. 2 log base 3 of x equals negative 1. Good. Divide by 2. Thank you, Vanessa. What? Loopy swoopy? So 3 to the negative 1/2 equals x. What the heck is 3 to the negative 1/2? What's a negative exponent do? I can't leave that. That's like breaking so many math rules right there. Oh, that was painful. Did you hear her? What's the negative exponent do with this? Puts it on the bottom. And then what's 1/2 exponent mean? It means a square root. But I can't leave that on the bottom. Oh, stop it. So radical 3 over 3. Is there a plus minus on that? That was a 3. Look at that. Why is there not a plus minus? She doesn't know. Did you ever instigate putting the square root into that problem? Guys, did you introduce the square root, or was it already there that you just switched it into the other form? It was already there. I never took the square root of both sides of the equation. That's when the plus minus shows up. It was already there. I didn't do it. This is fun stuff. You're missing out. All right, guys, how are we feeling? Great. We're almost there. Hang with me. We're almost there. Yeah. Eating what? Magnets? Oh, Jacob. I thought you said maggots at first. I'm like, what are you talking about? Yeah, so I'm like, come again? What? All right, here we go, guys. Natural log of x equals 2. What the heck is natural log? E. How do I rewrite natural log so that I can get that E in there? Just put an E on there. Guys, that's the same thing as log base E of x equals 2. Right? Natural log means log base E. That's what that means. You know, lazy mathematicians, instead of writing 4 letters log base E, I can write 2 letters of ln. Darn lazy mathematicians. So if you see that natural log, recognize that's log base E. So now can I loopy swoopy this? Yeah. E squared equals x. What is E? Yeah, just type it in. E is a number. E is a number. So x equals 7.3891. Double check the digit after that if you said 0. Yeah, so round it to 4 spots. That's not terrible, right? It's just recognizing that natural log is log base E. So the very next one, this is log base E of x minus 3 squared equals 4. Now, before we go any further with this, what do we do with exponents with our properties? Where do they go, the exponents? They go in front. Because if I put them in front, doesn't that make this problem a lot easier? So 2 log base E of x minus 3 equals 4. Anytime you have that exponent up there, if you can use your properties and throw that out in the front, now what do I do with that 2? Yeah, now I can divide by 2. Now, can you do this problem otherwise? Yes, you can. Bye, Vanessa. Thank you. So log base E of x minus 3 equals 2. Because you can do this problem without moving that exponent to the front. You could have done e to the 4th power equals x minus 3 squared, but it's a lot more work, a whole lot more work. It gets pretty ugly, okay? So I'm not even going to go there with you guys. This is easier. Take that exponent, put it out in front, then I can divide by it, and now it's a lot easier. So now I have e squared equals x minus 3. And then to get x by itself, we'll just add 3. Watch. 10.3891 equals x. She was right. And again, if I plug it in, do I end up with a negative inside of there? 10 something minus 3? That's not negative. I'm okay. How are we feeling so far, guys? You've been pretty quiet today. We all right? It is Friday. All right, guys, this is the last slide. Last slide, last 2 problems. Then I'm going to give you time to work on your homework. What? All right, on this first one, what should I do first? Pull the 2 out in front. Yeah, you got that exponent. Take your exponent out in front. Hey, guys, 2 problems. Hang with me. Good. So exponent, pull it out in front. Then we can divide by that. Makes it a lot easier. I'm going to also switch this to log base E at the same time. I did not do that earlier. Otherwise, you're like, wait a minute, what's my base? What's going on? All right, then what should I do? Loopy swoopy. So E squared equals 3x plus 5. Is this one where you might want to just kind of grab your calculator and start typing it in? Yeah. So grab your calculator. We'll type in E squared, hit equals. Then what? Minus 5, because you have to subtract that. Minus 5, and then what? And then divide it by 3. This is one of those where it's easier to just do it all straight in the calculator. So E squared minus 5, divide by 3. So we should get 0.7964. And again, double check if you would type this in. 3 times 0.7964 plus 5. Is that going to make a negative number? No, it's not. We got 1 to go. Hi. All right, what do you want to do on this one first? Smoosh. Yeah, you condense that down using your properties. So natural log, what do I do with these two numbers? You'll multiply them because of the plus. So 2x times 3 is 6x equals 2. Natural log is log base e, 6x equals 2. Loopy swoopy. So e squared equals 6x. And then divide by 6. Just have to grab that calculator. Beautiful. 1.2315. And again, double check. 2 times that, not negative, so I'm good. All right, let's recap real quick here, guys. We are, but I want to let's look at a few things. So when we're solving, because we've done a lot the last 2 days, right? We've done a lot. So let's say, let's do an example and kind of like how this works with all the different things we've done. So yesterday we focused on, for example, if I had like 6 to the 2x equals 6 to the 3x minus 1. How did you solve something like that? Good. So this is if they have the same base, you just set the exponents equal to each other. Equal and solve. Okay, I just want to make sure, like, you might want to jot this down like a condensed version, like, so I'm looking at all this solving stuff, especially Monday, we're going to do an activity dealing just with all this solving, just to make sure, like, we keep it straight, because there's a lot of different methods we kind of looked at. All right, also we talked about yesterday if the bases are not the same. So for example, if you had like 3 to the 3x plus 2 equals 7 to the 4x. So exponents equal. So you would set like 2x equals, yeah, so like 2x equals 3x minus 1, and then you would solve. No, you're fine. Good. So for something like this, where you have different bases, take the log of both sides. And solve. So Kelsey doesn't ask. I'll write it up here. No, you're fine, hon. So you'd have log of 3. Don't try to solve these. I'm making these up on the fly, so I don't know what they're going to turn out like. Equals log of 7 to the 4x. No, you're totally fine. You can do that. Because then this would make you move your exponents out in front, and then you could go through your solving process from there. Again, I made these on the fly, so just, you know. Right? That was what we did yesterday. And then today, what did we do? If you had like log base 3 of 4x equals log base 3, 7x plus 4. Good. So this is logs on both sides. It is. It's just like the top one. Logs on both sides, same. So set each parenthesis equal and solve. Yeah, so this one is kind of just like this one, where they have the same bases, they have the same logs, same idea. So for example, it'd be 4x equals 7x plus 4 and solve. What? Yeah. All that scary board's full of all this math stuff, and you're looking at this and you're understanding this, aren't you? Yeah. All right, what if you have like log of 3x plus 2 equals 7? What would you do with that? Loopy swoopy. So in this case, you have one log, right? Only one log on one side. You loopy swoopy. Loopy swoopy. That's right. I wrote it. I did it. Loopy swoopy. So in other words, well, that would be ugly if that was really a 7. It'd be 10 to the 7th equals 3x plus 2, and then you would solve from there. Loopy swoopy and solve. We'll just kind of put a little note on here, may have to condense logs. Right, because if I have like more than one piece in here, you may have to condense it down to a single log. And same thing with e's, little asterisk there. ln, rewrite as log base e before you can loopy swoopy that. Whew. All that solving, look at that. You're right, that does look like those crazy chalkboards in a movie.